Hello, everybody. Mrs. B here. We are starting Unit 7 today, Unit 7, Day 1, completely new unit. We're going to look at creating and solving proportions, determining if we have similar figures, and then knowing that we have similar figures, finding missing measures in them. So to get us started, I wanted to briefly talk about what a ratio is. So a ratio is comparing two quantities using division. So just some examples of ratios that you might be familiar with is talking about like a student to teacher ratio, aspect ratios for screens, the golden ratio, very famous, and pi. Pi is a ratio too. And we need to talk about ratios because our big thing here today is going to be about proportions. Proportions are comparing two equivalent ratios. So to start, I have two very basic examples where we want to figure out what x is. So looking at this first one here. So I know 3/7 is equal to x over 63. So a couple different ways that you can do this. The easiest way or the quickest way in this particular example is I notice that if I take 7 times 9, I get 63. If that's true, I need to take 3 times 9 and I'm going to get x is 27. Because again, these are equivalent. So if you reduced 27/63, you would get 3/7. Similar thing here, looking at the second example, 2/4 equals 24/x. Well, I knew 2 times 12 is 24. So that means if I take 4 times 12, I'm going to get x is 48. What about these examples? We can't use that same strategy with these examples anymore. They're a little bit more complex. So here we have two x's. So 2 over x minus 3 is equal to x over 4, or 11, I'm sorry, over 4x. So here our strategy is that we are going to cross multiply. So I'm going to take 2 times 4x. I'm going to set that equal to over here 11 times x minus 3. So I got rid of my fractions now, so I can go ahead and just do some simple algebra to solve. So on the left side here, 2 times 4x is 8x. Here I need to distribute this 11, 11x minus 33. I have x's on two sides of the equation. I just want it on one. So I'm going to subtract 11x from both sides. So I'm going to go away over here. Here I'm going to get negative 3x is equal to negative 33. My last step, divide by a negative 3. So that divides out here. Negative 33 divided by negative 3 is going to give me positive 11. Let's look at this example here. We have 1 over f is equal to f over 25. So I'm going to do that same thing. I'm going to cross multiply. So 1 times 25 equals f times f. So 1 times 25, that's just 25. F times f, that's going to give me f squared. So now to undo a square, I need to take the square root. Square root of f squared is just f. Square root of 25, a lot of you are going to be like, oh, super easy. That's just 5. But it's not just 5. Whenever you take the square root, you got to remember plus or minus. So f could be plus or minus 5 here. So let's look at another example, but put this into some context. So if eggs cost $2.04 a dozen, I don't know if you've been to the grocery store very recently, but that is a very expensive dozen eggs. But if it did cost $2.04 for a dozen, how much would 5 eggs cost? So before I can answer this question, I want to set up two ratios. I want to set up a proportion so I can figure this out. There's a couple of different ways, there's a lot of different ways actually that you could set this up. But what I'm going to do is I'm going to take that $2.04 and I'm going to put it over 12 eggs. So I know it's $2.04 per 12 eggs. I want to know how many dollars. I don't know how many, so I'm going to call that my variable. I'm going to call it X. I know that it's equal to 5 eggs. So notice here when I set up my proportion, I was consistent. That is the most important thing here. You have to be consistent. Since I put dollars on top of eggs on the left side, I need to have dollars on top of eggs on the right side. It has to stay consistent. So now that I have these numbers, I can just go ahead and use my method of cross multiplying here. So 2.04, $2.04 times 5 is equal to 12x. So on the left side there, all I have is a number, multiplying those out, and I get $10.20 equals 12x. I need to divide by 12, and that is going to give me x is equal to 0.85. And going back answering the question in context here, we would say 85 cents per 5 eggs. All right, now let's put this into a different context, switching gears a little bit and talking about similar figures. So we talked about congruent figures, specifically congruent triangles in first semester. And now we're going to be looking at what it means to be similar. So to be similar figures in math is to have the same shape, although not necessarily the same size. So in this first box here, I have 2 green triangles, and I can see that they look like they have the same shape to them, but this one is just a little bit smaller. It's also tilted, and that's totally fine. Whereas here, these 2 stars, this star looks a lot bigger, but it also looks way skinnier. So these are not the same size nor the same shape. So these are not similar figures, whereas these triangles, we could say that those are probably similar. So mathematically, we know that polygons are similar if and only if their corresponding angles are congruent and corresponding side lengths are proportional. So both of these things have to be true. We have to have congruent angles. We have to have proportional side lengths. So here I have 2 polygons. I have 2 quadrilaterals. And in order to say that they're similar, we have to know that their corresponding angles are congruent. So I notice that these are not in the same orientation, and that's going to be a really common thing to see. You're not always going to see shapes in the same orientation. So I'm just going to kind of imagine what this would look like if they were, to help me figure out what angles are going to go together. So it looks like angle S and angle D, like those would be corresponding. Those look like the same measure. Then I have angle E. Looks like it corresponds to angle U. Angle P corresponds to angle B. And angle T corresponds to angle A. So as long as we know that those are congruent, that's the first step. The next is knowing that the side lengths are proportional. So that means that if I set up ratios for each of the corresponding sides, they need to reduce to the same thing. So if I start here between my 1 angle and 2 angle, we have a 4. Over on this polygon, that corresponds to a 6. And then between a 2 and a 3, I have a 6. Between a 2 and a 3, I have a 9. And then a 3 and a 4, I have an 8. 3 and a 4, I have 12. And my last side lengths, I got a 4 and a 6. Now, I am not sure if those are equal. I'm checking, so I'm putting a little question mark. And I want to go ahead and reduce each of these fractions. So 4 over 6, those are both divisible by 2, so we get 2/3. 6 over 9, those are both divisible by 3, we also get 2/3. 8 over 12, divisible by 4, 2/3. 4 over 6, also 2/3. So because they reduced to the same, each of those ratios reduced to 2/3, we know that those side lengths are proportional. So we can say these figures are similar. So here we have two triangles. Like I said, we're going to be looking a lot at similar triangles in this chapter, this unit. So given triangle SUP, this is the symbol for similar that we use. So a little squiggle, this means similar. Triangle BWL, what other information do we know? So just like when we talked about congruent triangles, I didn't just name these triangles in any way that I wanted to. I named them in a very particular way. You have to pay attention to the order of the letters because it tells you the corresponding parts. So I'm looking at these two triangles. I see that we know some angles, but we don't know all. So I want to figure out what the other angles are. Now, again, with similar figures, we know that all angles are going to be congruent. So first, I know angle S is 36 degrees. S is the first letter in the first triangle. B is the first letter in the second triangle. So those two angles correspond. Those two have to be congruent. So B also has to be 36 degrees. In this triangle, I know angle W is 117 degrees. Angle W is the second letter. The second letter in the first triangle is U, so I know those correspond and they have to be congruent. Oh, I wrote the wrong number there. So this has to be 117 degrees. And then lastly, I don't know anything about angle L and angle P, but I know that they correspond also. I don't know either of them, but thankfully I know that the angles in a triangle add up to 180 degrees. So if I take 180 minus 117 minus 36, I get what's left over, and I get 27 degrees for each of those. So again, similar, all angles are congruent, and the other thing that we know about similar figures is that all sides are proportional. So for instance, if I'm looking at side SP, so if I'm looking at this side right here, I know that this is 6. And I'm looking up here, I know SP, first and last, has to correspond with BL, first and last. So BL right here. So I can set up a ratio. Actually, I should write the letters first. I know SP corresponds with BL. And then let's see, I will use, what color haven't I used? Purple. All right, then if I want to look at SU, so SU, first and second, BW. first and second. So I got this side here. And then I'll use, how about this darker green? We have UP. We have the last two letters WL. So now that I have my ratios set up with my side lengths, with the names, I can go ahead and I can plug in the values that I know. So I know SP is 6. I know BL is 12. I'm not sure what SU is, so I'm just going to keep that. I know that BW is 6. UP, I know that that's 4. WL, I'm not sure what that is. But if you notice here now, I know this whole ratio and I have two unknowns here. So I can go ahead and use the ratio I know to solve for my missing sides here. So I know that the triangle, the first ratio, the sides are proportional by 6/12. So 6/12 reduces to 1/2. So if this is equal to 1/2, these have to be equal to 1/2 as well. Notice I didn't put question marks here because I know that the triangles are similar. So I can use that. I know that these have to be equal. So if SU over 6 has to reduce to 1/2, that means that SU has to be 3 because 3/6 reduces to 1/2. If I know 4/WL has to reduce to 1/2, I know WL has to be equal to 8. All right, one last example, a little bit less here. So in this example, I'm given that my two triangles are similar. ABC is similar to DEF. Then I know some side lengths. So I'm going to go ahead and I'm going to fill those in. So AB, x plus 14, BC is 17, DE is 1, EF is 2. And I want to find AB. So I'm going to set up my ratios first. So AB and DE correspond. And then I know what BC is. So I'm going to use that to help me. BC corresponds with EF. So now that I know what my sides are called, I'm going to fill in the numbers that I know. So AB is x plus 14. DE is 1. BC is 17. EF is 2. Now I'm going to go ahead and I'm going to solve this just the same way we did at the beginning of this video by cross multiplying. 2 times x plus 14 is equal to 1 times 17. So I need to distribute that to 2x plus 28 is equal to 17. And then I did something wrong. Nope, sorry, did not do something wrong. I was getting confused here and you'll kind of see why in a sec. So I am going to subtract 28 from both sides to get x by itself. 17 minus 28 is negative 11. Next, I'm going to divide by 2. And 11 divided by 2, negative, we can keep that, negative 11 over 2. That's also negative 5.5. So I'm going to go back up. Notice I wanted to find AB. That's what I wanted to find. And I know AB is equal to x plus 14. Well, I know what x is now, so negative 5.5 plus 14. And that gives me 0.5 for AB. All right, so that's what I got for you. If you have questions while you're working through your homework, let your teacher know. Good luck.